Hi, this is John Linneball, and I am with John Linneball Tutoring, and this is how to study for the SAT and ACT math sections factoring. Here's my contact information if you have any questions or comments about this video, and you can also use this if you want to get in touch with me about tutoring. So what is factoring and why should we care? I'm glad you asked. The factoring is breaking down integers into the integers that you can multiply to get those integers as a product. I know that's confusing. Anyway, I don't mean factoring polynomials where you have to solve a quadratic equation by factoring. That's not what I mean. Basically, what I mean is you take a number like 12 and you can break that down into 4 times 3, and then you can break 4 down into 2 times 2, so 12 is equal to 2 times 2 times 3. It's basically taking the prime factorization, but you don't always have to go all the way to the prime numbers. You should care because it's the easiest way to multiply and divide on the SAT non-calculator section and sometimes even the calculator section. It's a very classic SAT problem, especially from the days before they let you use a calculator, that you'd have some big ugly numbers and you're dividing one by the other. And the trick is if you could factor the numbers, it'd be very easy to do without a calculator because they were contrived SAT problems. So the ACT is all in quotes calculator, but again, if you know how to factor effectively, you can do it faster with your pencil and paper than with a calculator. It does take time to reach it, turn it on, type in the numbers, check it to make sure you didn't type in the wrong numbers, etc. Finally, a calculator won't find the greatest common factor or lowest common multiple of two numbers unless you have it specially programmed, but factoring will. There is an algorithm to do this called Euclid's algorithm, and here's the URL on calculatorsoup.com, and we will see this again. So there's the URL if you want to go look, but we will see this a couple slides from now. So the first thing you need to know is to know how to do a prime factorization. A prime factorization is when you break a number down into all the prime numbers that are factors of that number. So for example, here we have 24, and it's equal to 12 times 2. So we factored out one prime number, 2. That goes all the way to the bottom. Then we have 12, 2 times 6. Okay, so just like a tree, it branches off. You have 6 goes to 2 by 3, and the original 2 and the 2 times 6 just drops to the bottom. So at the bottom, we have what's called the line of prime factorization. It's 2 times 2 times 3 times 2. So you can think of the line of prime factorization as the presents at the bottom of the factoring Christmas tree. Just what I always wanted. Anyway, in case you don't know what a prime number is a positive integer greater than 1 that has only itself and 1 as its positive integer factors. Notice that 1 is not a prime number and 2 is the only even prime number. Let's take that prime factorization of 140. We can easily see that 140 is equal to 14 times 10, which then you can see 14 is 7 times 2, 10 is 2 times 5, so then you can break it down into 7 times 2 times 2 times 5. So the prime factors of 140 are 7, 2, 2, and 5. If you want to write it as 7 times 2 squared times 5, knock yourself out. That's great. Know your multiplication tables up to at least 12. You can't divide or factor effectively if you can't multiply numbers up to 10 in your head. So you should have memorized those when you were in third, maybe fourth grade. If you haven't or you need to brush up on it, please do. 11 is really easy because 11 times any single digit integer is just going to be that integer twice. So 11 times 2 is 22. 11 times 3 is 33. 11 times 4 is 44. If you see a two-digit number where the digits are the same, you know that 11 is a factor of that number, and the other factor is the digit. So you see 66, you know it's 6 times 11. And then 11 times 10 is 110, 11 times 11 is 121, 11 times 12 is 132. 12 is good to know because 12 is a number frequently used in commerce, a case of many things like cans of soup, cans of soda, etc. They contain 12. So sometimes a case of a beverage might be 24, but either way, it's either 12 or it's a multiple of 12. You should know the multiples of 12 up to 144. 12 times 12 is 144, which is also a gross. That's used a lot in commerce. In fact, that's where the word grocery comes from, is because food vendors would buy things by the gross, so they buy 12 cases of it and sell them. It also comes up in geometry. 12 is a factor of 180, thus also 360. So anything, if you're working with degrees in geometry, 12 is often a number that you're going to be looking at as part of the problem because, again, it makes for nice, neat, contrived SAT or ACT problems. It also comes up in time because 5 times 12 is 60. So it's really good to know that 1/5 of an hour is 12 minutes, or 1/12 of an hour is 5 minutes, just from the numbers on the clock. When you're doing SAT problems, or even if you're tracking time on the job where you charge by the hour, if you know, oh, 12 minutes, that's 1/5 of an hour, 5 minutes, that's 1/12 of an hour, that's going to help you a lot when you have to multiply the time that you work times your rate to charge a customer. 15 is also useful in geometry and time. 15 minutes is a quarter hour. 15 goes into 180, and in fact, 180 is 15 times 12. So for the reasons we just discussed about 12, 15 is also a really good number to know for geometry problems and for factoring things out. Euclid's algorithm. Okay, here it is again. HTTPS, all right, blah, blah, blah. Calculatorsoup.com/calculators/math/GCF or greatest common factor.php. You can find a nice explanation there if you have trouble following this explanation. Anyway, I don't know if you really need to know this for the SAT or ACT, but it can't hurt to know it. Knowing more than one way to solve a problem is always a good thing, as long as you understand both of them. It is probably the best way to program the computer or your calculator to do it, or to find the GCF of gigantic numbers. You can see the web page for examples. The SAT and ACT aren't going to give you problems like find the greatest common factor of 103,455, 103,453, and 123,452, but you can also use it for smaller numbers, as we'll see in a second. How does Euclid's algorithm work? First, you want to take the whole numbers for which you want to find the GCF, let's say 57 and 18. The second thing you're going to do is subtract the smaller number from the larger number. So here you're going to subtract 18 from 57, you get 39. And then you take the result, 39, and you subtract the smaller number, 18, from it. So, oops, let's go back here. Okay, 39 minus 18 is 21. And you just keep repeating that until the smaller number is larger than the result. So 21 minus 18 is 3. And then you say, oh, okay, well, the result is smaller than the smaller number. Then you're going to subtract the result from the smaller number and keep repeating till the result is 0. So in our example here, it'd be 18 minus 3 is 15. 15 minus 3 is 12. 12 minus 3 is 9. So you can see we're just subtracting 3 from a multiple of 3. So you should be able to figure out that the last one's going to be 3 minus 3 equals 0. So you want to take one step backwards. The result before the result became 0, which would be 3, is going to be the greatest common factor. Here it's 3, as I just said, which makes sense because 57 is 19 times 3, and 18 is 3 times 6. So, and 19, of course, is prime, which means its only factors are 1 in itself, so it can't have any common factors larger than 1 with 6 or with any other integer. So, all right, we know that's got to be the right answer, that the greatest common factor is just 3. You don't even have to factor down to primes, though, for this method to help. In fact, it's better if you don't. If you can find a larger common factor, then you just stop dividing and just basically divide each number by that factor. So if you know that 120 is equal to 6 times 20 and 100 is equal to 5 times 20, you don't have to factor 120 to 12 times 10, which is 2 times 2 times 3 times 2 times 5, and then 100 is 2 times 5 times 2 times 5, when you can just see, okay, 120 over 100 is 20 times 6 over 20 times 5, which is equal to 6 times 5. And you can see a few different ways you can factor something. You can make 140 is 10 times 14. So if you had 140 divided by 60, you wouldn't even have to do all this 2 times 5 times 2 times 7, 2 times 3 times 2 times 5. You just go, oh, okay, I divide both of these. All of a sudden, If I have 140 over 60, it's 10 times 14 over 10 times 6. Boom, the 10s cancel out, end up with 14 over 6. Divide 14 and 6 both by 2, so then I end up with 7 over 3. That fraction is now in its reduced state. Can't be reduced any further. Same thing with 54. If you have 54 over 27 and you recognize, oh, 54 is 2 times 27, and I'm dividing by 27, then boom, you know the result is 2 because the 27s cancel out. You don't have to do all this factoring. So, how should excuse me. So, how should I factor then? Well, I'm glad you asked. Let's do some examples. Let's do a few examples from official College Board SAT practice tests. For example, this is test 1, section 3, question 17. This is from the first of 8 tests you can download from the official College Board site. They have PDFs, Adobe Acrobat files that are contained in these zip files. You can find them very easily. If you have trouble, get in touch with me. I'll find them for you, or I'll just send you copies of the ones that I downloaded. All right. So first, x is the length of AE. So we can see AE is right here, and it's x. Now, we know that these triangles have 2 congruent angles. How do I know that? Because they show you the little line that tells you these 2 are equal, and these angles here are vertical angles, and by definition, they are congruent. So, we know that AE is proportional to CD, and then that means that BE has to be proportional to BD. Why? Well, because we can see here's the angle. This side is obviously proportional to this side. So since this angle here is formed with this one, with BE, then BD must be proportionate to BE because it's the angle between the base and this side. Anyway, you're both on the side of the marked angle, so we know that they have to be proportionate to each other. All right, so BE over BD is equal to AE over CD. So then we know that BE is 1400 over 1700. Oh, okay, that's just 2. And proportion to AE over CD, so that's going to be something over 800. So we see x 1400 over 1700, or not over 1400 over 700, not 1700, is x over 800. We can break that down into 2 times 700 over 700. Boom, the 700s cancel out. So we get 2 is equal to x over 100. We see they cancel out, so then you just get 800 times 2 equals 1600. Boom, it's 1600. And I wrote the side lengths on this figure because it wasn't in the question. It was in the question, but it wasn't on the figure. That is another word to the wise, is if they give you numbers here and they give you a diagram that's drawn to scale, then you want to put this on here right away. Especially if they give you a diagram that's not drawn to scale, you should redraw it and also put the values from the problem on there so it's easier for you to see what's going on. All right. So here's another example. This is test 1, section 4, question 31. It says, Wyatt can husk at least 12 dozen ears of corn per hour and at most 18 dozen ears of corn per hour. Based on this information, what is a possible amount of time in hours that it could take Wyatt to husk 72 dozen ears of corn? All right, first you need to know that work equals rate times time, just like distance equals rate times time. So we know that 72 dozen is equal to 12 dozen per hour times h hours. Okay, so we know that 72 is equal to 6 times 12. So then 72 over 12 is just going to be equal to 6 because the 12s cancel out. 72 dozen could also be 18 dozen per hour times h hours. Now we also know that 72 is 4 times 18. So 72 over 18 is equal to 4. So any number between 4 and 6 that you could grid into the grid in question there would work. I would probably just pick 4 or pick 6 and put it in there, or just put 5, split the difference. Go crazy. All right, So let's do another problem here. Test 1, Section 3, Question 14. First, we want to solve for y. Y is equal to 3x minus 12. Well, how did we do that? We just added y to each side. We have 3x minus y equals 12. So we just add y to each side. You get 3x is equal to 12 plus y. Subtract 12 from each side, then y is going to be equal to 3x minus 12. Now we know that they're asking what is the value of 8 to the x times 2 to the y. All right, well, one thing that we do know is that 8 is equal to 2 cubed. So that's going to be, so 8 to x power is just going to be 2 to the 3x power. And so the initial expression becomes 2 to the 3x, and then over 2 to the y, which is divided by 2 to the 3x minus 12, because we know that y is equal to 3x minus 12. So when you divide powers of the same number, you just subtract the exponents. You subtract the bottom from the number on the exponent on the bottom from the one on the top, so it becomes 3x minus, yeah, okay, 3x minus 12, which is going to be 2 to the 12. And you can see I made a typographical error. That should be 3x minus 12, not 2x minus 12. So sorry about that. That should be 3x minus 12. You end up with 2 to the 12, which is answer A. All right. Let's do a couple of questions that I made up. Bill and Bob's Excellent Adventure. The distance from Detroit, Michigan, USA to Melbourne, Victoria, Australia is approximately 16,000 kilometers. Bill and Bob are planning a trip from Melbourne to Detroit next July to meet a lot of Bill's friends. A kilometer is approximately 5/8 of a mile. On that direct route, the average speed of the Boeing 787 Dreamliner, operated by Wallaby Airlines, the carrier that will take Bill and Bob to Detroit, is 500 miles per hour. How long does the flight take? Notice that the time is listed in the picture, this 21 hours and 35 minutes, is for a flight with stops, not for a direct flight. So don't try to cheat and use this number. All right, so how do we do it? First, we should either convert 16,000 kilometers to miles or 500 miles per hour to kilometers per hour. Either way, the conversion factor is 5 miles per 8 kilometers, which is the same as 8 kilometers per 5 miles. Why? Because we know that 5 miles is equal to 8 kilometers. So it doesn't matter. It's just like having 1 over 1 or 1 over 1. So anyway, let's try 16,000 kilometers times 5 miles over 8 kilometers. All right, so the first thing we want to make sure is, do the units cancel out? Hopefully in physics or chemistry you've learned that. So that's going to be kilometer, kilometer. Oh, good. That's on the top of the fraction. That's on the bottom. So boom, kilometers cancel out. So we strike that out. And it's 8 times 2,000. Oh, okay, over 8 times the kilometers. So boom, the 8's cancel out. So then you end up with 2,000 times 5 miles. 2,000 times 5 miles is 10,000 miles. So now we need to divide 10,000 miles by 500 miles per hour. And when you divide a fraction by a fraction, you can just flip the fraction to multiply. So we see that 10,000 miles divided by miles per hour, you end up with miles divided by miles, which cancels out, and hour on the top. So you get 10,000 times 1 hour over 500 miles. The miles cancel out, and you're multiplying by 20 hours. So you get 10,000 over 500, which is going to be just equal to 20 hours. Why? Because 500 times 20 is 10,000. So again, 10,000 times 1 hour over 500 miles. Okay, the miles cancel out. 500 times 20 is the 10,000. Divided by 500 is just equal to 20 hours. So we know Bill and Bob's Excellent Adventure will take 20 hours. Another question I made up. Jesse runs into an emergency that makes it necessary for him to leave his hometown of Albuquerque, New Mexico. His friend Ed, up here, suggests that moving to Haines, Alaska would be better for Jesse's health, and offers him a ride in exchange for expense, gas, etc. money in the amount of $125,000. The distance from Albuquerque to Haines is approximately 3,000 miles. The price of gas at Costco in Albuquerque for Ed's panel truck is approximately $2.25 per gallon. Really, I checked it on the Costco website a few days ago. Anyway, however, gas is more expensive in other towns and cities along the route, including cities in Canada. So let's assume the average cost for a gallon is going to be about $3. Ed's panel truck gets roughly 24 miles per gallon. What would Ed's other expenses be once the cost of gas was subtracted? All right, first we have Jesse's and Ed, big adventure continued. All right, first we have to determine how many gallons of gas we need. So we divide, notice how I cross it out here, the number of miles by the mileage per gallon. Notice that 3,000 equals 3 times 1,000 and 24 is 3 times 8. So 3 times 1,000 miles divided by 8 times 3 miles per gallon. All right, the 3's cancel out, boom, boom. So we end up with 1,000 over 8 gallons because the miles also cancel out. So notice that those miles units cancel out. Again, if the units don't work out, if you end up with 1 over mile or something like that, or 1 over gallon, something you weren't expecting, that means you probably have the conversion factors flipped wrong, and try flipping it over so the right units cancel out and you end up with the unit you want. That certainly saved me from getting a lot of wrong answers in chemistry and physics in high school. So we're using roughly 125 gallons of gas. 125 gallons times $3 per gallon is $375. So Ed's other expenses are $125,000 minus $375. So that's $124,625. Wow, those must be some real expenses. So we can easily make up another 2 SAT type problems for this scenario. 1 kilometer is approximately 5/8 of a mile. The distance between Haines and Albuquerque is approximately 3,000 miles. How many kilometers is the distance? Assuming Jesse and Ed make the trip in the 50 hours Google Maps predicts, what would their average speed be in kilometers per hour? Wrote by instead of be here. Oh well. Anyway, 3,000 miles is equal to 8 kilometers over 5 miles, which is going to be 5 times 600 miles divided by 8 kilometers per 5 miles. Notice that you have miles on the top, miles on the bottom here, 600 miles on the top, divided by miles on the bottom. That cancels out. There's a 5 on the top, 5 on the bottom. The 5's cancel out. So you end up with 600 times 8 kilometers is equal to 4,800 kilometers. So the average speed in kilometers per hour is 4,800 kilometers over 50 hours. That's 48 times 100 kilometers divided by 50 hours. 48 times 50 is, times 2 kilometers, and then divided by 50 hours. Because you can see 48 times 100, 100 is 50 times 2. So then the 50 on the top and the 50 on the bottom cancel out, so you end up with 96 kilometers per hour, which is, roughly highway speed. It's a little bit more than 60 miles per hour. So, all right. I hope this helped. If you have any comments or questions, please leave a comment below or contact me at the phone or email at the beginning of the video. If you like this and want to help me make more videos, please like this video and subscribe to this channel. I do in-person and online tutoring for the SAT, ACT, and more. And again, thanks for watching this. Please like, subscribe, comment. I do reserve the right to delete comments that are off topic or just abusive or spammy or whatever. But other than that, happy to hear from you. Please let me know what you think of this video. Thanks. Have a nice day.